Hi there. Welcome to the Abaqus tutorials. In this video, I will explain how to create a model database in Abaqus for different purposes. Abaqus has 3 model database options. With standard or explicit model. With computational fluid dynamics model. With electromagnetic model. The heart of Abaqus is the analysis modules, Abaqus Standard and Abaqus Explicit. These solvers are based on 2 approaches in FEM analysis, namely implicit, for Abaqus Standard, and explicit. The distinction between the 2 different numerical approaches makes it possible to understand which solver to use. In the case of the implicit method, equilibrium is enforced between externally applied load and internally generated reaction forces at every solution step, Newton-Raphson method. In the case of the explicit method, there is no enforcement of equilibrium. But this does not mean that explicit is not accurate. You can minimize its deviation from equilibrium to almost zero by increasing the number of solution steps, i.e. reducing the time step size. We can list the main differences between implicit and explicit. Implicit is unconditionally stable. Implicit schema is incremental as well as iterative. However, the explicit schema is only incremental. In terms of cost per increment, it is costly for implicit and cheaper for explicit. Disk space and memory usage are typically much smaller for explicit than that for implicit. The explicit method shows great cost savings over the implicit method as the model size increases. Therefore, Abaqus Standard must iterate to determine the solution to a nonlinear problem. But Abaqus Explicit determines the solution without iterating by explicitly advancing the kinematic state from the previous increment. You may have doubts about whether explicit or standard, which one to use. For many analyses, it is clear whether Abaqus Standard or Abaqus Explicit should be used. For example, Abaqus Standard is more efficient for solving smooth nonlinear problems. On the other hand, Abaqus Explicit is the clear choice for high-speed dynamic analyses such as crash analysis or drop test. There are, however, certain problems that can be simulated well with either program. Typically, these are problems that usually Abaqus Standard can solve but may have difficulty converging because of contact or material complexities, resulting in a large number of iterations. For example, in problems where very complex contact conditions or very large deformations are present. Such analyses are expensive in Abaqus Standard because each iteration requires solving a large set of linear equations. Abaqus Standard can be used for static and quasi-static problems. Abaqus Explicit can be used for quasi-static and dynamic problems. Structural analyses are an example of static problems. Metal forming is an example of a quasi-static problem. Impact problems are an example of dynamic problems. With CFD model. Abaqus CFD provides advanced, scalable and parallel computational fluid dynamics for a broad range of simulations. These cover an extensive range of fluid structural and nonlinear coupled fluid thermal problems. With electromagnetic model. Abaqus provides computational electromagnetic capabilities for the simulation of problems involving steady-state electrical conduction, piezoelectric phenomena, and low-frequency eddy currents. Please subscribe to this YouTube channel, proud to be a civil engineer, for more civil engineering-related videos and Abaqus tutorials. Thanks for watching the Abaqus tutorial video.